Good morning students, welcome back to PTSP online class. In this class I am going to talk about the properties of autocorrelation function and we left with the two topics in the fourth unit, that is properties of autocorrelation function and the properties of the cross correlation function. From these two topics one question can be asked in the exam. So here I am going with the two properties of autocorrelation function, and here this autocorrelation function, before going to study the properties of autocorrelation function, we will be going through some considerations. Here we will be considering a random process is x of t. Here we are considering x of t is a random process. At least it is a wide sense stationary random process. In the previous classes we have discussed the various types of random stationary random process. The stationary random process is a one in which all the statistical properties remain same at the various time instants. That means what? Even with the time shift also, if the statistical properties of the time process does not change, then that is called, it is a stationary random process. And we will be considering here x of t is a random process. It is at least the wide sense stationary random process. It is with the second order one. The previous classes we have discussed this one. In the wide sense stationary process, we have, that is tau is a time difference that is between the t2 and t1. We can call tau is equals to t2 minus t1. And in case of wide sense stationary process, we have the expectations that is e of x of t into and x of t plus tau is nothing but it is a time difference, which we have proved the autocorrelation function, that is rxx of tau. So these are the three considerations. We are going to include all these three considerations in the study of the various properties of autocorrelation. First consideration is what? It is x of t is a random process, and that is at least the wide sense stationary process, in which we will be considering the time difference is about tau is t2 minus t1, and the expectations of x of t and the x of t plus tau, and it is the new random variable, is equals to autocorrelation function of tau. By keeping these things in the mind, we can go with the various properties of autocorrelation. Then first I am going with the one of the important property of the autocorrelation, that is a mean square value of a random process x of t is expectations of x square of t is equals to autocorrelation function. So here x of t is what? It is a random process, and for this random process we have to calculate the mean square value of that random process, and that is given as e of x square of t is equals to the autocorrelation function of 0. Rxx is nothing but it is an autocorrelation function. Here it is equal to the power average of the process. Whenever we are squaring any signal or any process, then we can call it as a power signal, so that it is squaring nothing but it is a power signal, and it is in the finite range, so that it is called as the power signal. So that this process is the average, it is equal to the power average of the process. So that to prove this one, what we have to prove? That means e of x square of t is equals to autocorrelation function of 0. Autocorrelation means it is the correlation between the two random variables within the same random process. Then coming to here, I am going with the proof. This is 4 steps for the proof. For x of t we know that it is a random process. For the random process we will be having, and in these two, the same random process, we will be choosing the two random variables. One is x of t, another one is x of t plus tau. and both will be chosen at the two time instance, so that it is given as e of x of t and x of t plus tau. If I consider tau is equals to 0, if I go with the tau is equals to 0, then I can replace r x x of tau is nothing but 0 is equals to expectations of x of t and x of t plus tau is 0 here, so that it is x of t and x of t, then you can call it is e of x square of t. We have to prove that the mean square, this is a mean square of x of t, mean square of x of t must be the autocorrelation function at tau is equals to 0. There is no time shift. That means what? We have chosen the two random variables. One is at x, one is at t, another one is at t plus tau, where we are considering the tau is 0, so that both are same random variables only. For them, mean will be square of that signal only, so the square of that particular random variable only, so that it is a autocorrelation function at tau is equals to 0 is nothing but the mean of that particular signal only. In other words, we can tell that power average of this process, power average of that process is nothing but the autocorrelation at tau is equals to 0. This is one of the important property of the autocorrelation function. Here I am concluding the autocorrelation function, one of the property. First one, we will be considering x of t is a random process. X of t is a random process. It is at least the wide sense stationary random process. Wide sense stationary random process is nothing but stationary random process means if the statistical properties of the random process doesn't vary with respect to the time shift, then that is called as a stationary random process. Otherwise, it is a non-stationary random process. When we are talking about the stationary random process with respect to the second order, then that is called, it is a wide sense stationary random process. We know that if a random process x of t is a second order stationary process, then it is called a wide sense stationary process or weak sense stationary process. For the condition is what? E of x of t into x of t plus tau is equals to rx x of tau. Here e is nothing but x of t, and it is x of t is nothing but it is a random variable chosen at t, and it is another random variable which is chosen at the t plus tau, and we are considering here this is tau is 0, so that expectations of these two product signal will be equals to the autocorrelation of that particular at tau is equals to 0. This is about the one of the important property of the autocorrelation. Then I am going for the next property of the autocorrelation function. This is very, very important in the examination point of view. In the exam, any 5 properties of autocorrelation function can be asked for the long answer question, so that these are very, very important in the 4th unit. And the 4th unit, so far we have discussed the various random processes, various stationary processes, and various levels of distribution density functions, and all these will be asked in the definitions only. But whereas in the properties of autocorrelation and the cross correlation will be asked for the proof also, so that these are very, very important. Autocorrelation properties and the cross correlation properties are very important for the examination point of view. From these two properties only we can expect the one long answer question. So that I am going with the second property of the autocorrelation function, that is autocorrelation function is maximum at the origin. Origin is nothing but at t is equals to 0, you can call it is autocorrelation function. That is what? Autocorrelation function, that is rxx of t, that is called autocorrelation function, must be maximum at the t is equals to 0 only. Here this is rxx of 0. This is what it is, a autocorrelation function is maximum at tau is equals to 0, that is rxx of tau. that may be positive or negative value must be less than or is equals to the autocorrelation function at the origin. That means what? Whatever may be the autocorrelation function due to the various values of tau may be anything, but that will be less than or equals to the autocorrelation function at the origin only. That means what? From the words we can conclude that autocorrelation function is maximum only at the origin, and the remaining autocorrelation functions at the various values of tau or t can be less than or equals to the autocorrelation function at the origin only. So that here we know that autocorrelation function can be defined within the random process only. This is the random process, that is x of t, in which we will be choosing the two random variables, that is x of t1 and x of t2. These are the two random variables, and this is a random variable at the time instant t1, and this is the random variable that is time t2. Here the point is very clear that autocorrelation can be defined in the within the same random process. It is between the two random variables and which are belongings to the same random process, and these two random variables can be chosen at the two different instant of times t1 and t2. xt1 is one random variable, xt2 is another random variable, and t1 and t2 are the two different distinct time instants respectively. So that I am going with the autocorrelation function. I am going to prove the autocorrelation function is maximum at its origin only. So that x of t1 and x of t2, I am going with the x of t1 and x of t2 are the two random variables of the x of t at the two different time intervals t1 and t2 respectively. So consider a positive quantity only, consider the positive quantity, so that I am squaring this one. Consider a positive quantity means x of t1 plus or minus x of t2 and whole square, and this will be the positive one only. If this gets the x t1 plus or minus x of t2 is positive, square will be the positive only. If this x of t1 plus or minus x of t2, if we get this is negative, square will be the again it is positive only, negative square it will be the again positive only. So here this will be having what it is, if this whatever the term is there inside the bracket, whether it is positive or negative, we are making the square of that one, that will be the greater than 0 only, that is positive one only. So that consider a positive quantity, that is x of t1 plus or minus x of t2 whole square must be greater than or is equals to 0. And now I am taking the expectations on both sides, so that expectations nothing but e of something, and here also e of something. I will be taking the expectation on both sides, e of x of t1 plus or minus x of t2 and whole square greater than or is equals to expectation of 0, and this will be a plus b whole square. This is in the form of a plus b whole square. We can convert that into e of a square plus b square plus 2ab, we know that. So that I am converting, that is e of a square, that is x square of t1, and next one is about plus e of x square of t2 plus 2ab, it is 2 into AB means this into this, and we are applying the expectations on each term, so that it will be like this. So that we know that from the first property it is clear that mean of the random process, or the mean of a random variable which is chosen at the one particular instant of time, that is nothing but it is a autocorrelation function at the origin only. We have discussed this one in the previous property only. See this one, mean square value will be the autocorrelation function at origin only. So that e of x square of t will be r x of 0. So that by using the first property, by using the first autocorrelation property, we can write this is E of x square of t1 will be Rx, that is autocorrelation function at the origin. This is also autocorrelation function at the origin, plus or minus 2 into here. We can write this one is x of t1 and x of t2. You can write that is a autocorrelation function at the two instant of times, and t1 and t2. Autocorrelation function is at the t1 and t2. Autocorrelation function between the two different time instant, that is t1 and t2, must be greater than or is equals to 0. Here in case of wide sense stationary process, we know that in case of wide sense stationary process, tau is equals to t2 minus t1, so that here you can take this is a autocorrelation function between the t2 and t1, so that you can write this is about this is right, you can 2rxx of tau only. This is a autocorrelation function between the two instant of times only, so that I can write this is about Rxx of 0. This is the autocorrelation function at the origin. This is also autocorrelation function at the origin, and this is the autocorrelation function at tau, that is tau we know that it is t2 minus t1. Then this is autocorrelation function at the origin, and this is also autocorrelation function at the origin. This is 1 and 1, this is 2rxx of 0. That means what? 2 autocorrelation function at origin plus or minus 2 into autocorrelation function at tau. Tau is nothing but t2 minus t1. So that you are having 2rxx of 0 plus or minus 2rxx of tau greater than or is equals to 0. So that I can take this rxx of 0. 2 will be get cancelled if get the goes to the right hand side, that will be by 2 only, so that by 2 means 0 by 2 will be 0 only, so that rxx of that is autocorrelation at the origin plus or minus autocorrelation at the tau greater than or is equals to 0. If I take this 2 here, and that will be autocorrelation at the origin must be greater than or is equals to autocorrelation. This will be plus or minus, again I can get this will be autocorrelation of at the autocorrelation between the t1 and t2, that is nothing but autocorrelation at the tau only, so that then whatever may be the value of tau, whatever may be the value of t1 and t2, whatever may be the values of t1 t2 are, in other words we can tell that whatever may be the random variables chosen at the two time intervals within the same random process x of t, their autocorrelation function must be less than or is equals to autocorrelation function which is defined at the origin only. Here from this point it is very clear that autocorrelation function is maximum at the origin only. Within the same random process you have chosen any random variables at the any distinct of times, and due to those times we will be defining the autocorrelation function whose value always less than or equals to the autocorrelation function which is at the origin. That means autocorrelation function is maximum at the origin only. Autocorrelation function is maximum at the origin only. Likewise you can go through the remaining properties. In the next class I am going to talk about some other properties. In total we will be having the nine autocorrelation function, in which we have discussed the 2, and the 9 I will be giving the names of all the 9s. First one is the mean square value, and the second one is about the maximum autocorrelation function, and the next one is we have to prove that the autocorrelation function even function or the odd function. And you should know that even function means, for example, we will be having x of t is a signal. If x of t is equals to x of minus t, then that is called as a even signal. if x of t is equals to minus of minus x of t, then that is called the odd signal. With based on this concept, we are going to define the even function, even autocorrelation function and odd correlation function. In this we are going with even means what? If autocorrelation function defined at the time tau is same as the autocorrelation function if the tau is replaced by minus tau, then if these two are equal, we can call it is the even autocorrelation function. If these two are not equals, then that is called as this is an odd autocorrelation function. And that is the third one. And the last, the fourth one, we must study the fourth onwards. We must study the autocorrelation functions with the ergodic functions. In the previous classes, we have discussed the ergodic process, and the next class I am going to talk about the some of the important autocorrelations properties, and this is very very important in the examination point of view. Autocorrelation properties and the cross correlation properties are very much important in the examination, so that from these two topics only we can expect the one long answer question, so that everybody must be cautious about these properties, and such that we can get the maximum of marks from the fourth unit. That is, we can expect the maximum of 15 marks from the fourth unit, so that some definitions will be asked in the 2 or 3 marks questions, and the properties, that is autocorrelation properties and the cross correlation properties, will be asked for the long answer questions. So that students very very careful about this properties of autocorrelation and as well as cross correlation. Thank you student. Thank you so much.